we have to find out the value. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4 and 0, 5, and the end of this period 0, 5, which is the start of 0, 6. These are all start of these years. So end of 0, 5 is start of year 2006. We have these payments occurring. Annual payment occurring, which goes on till the end of 2025, which is 26 here. So this is 06, 07, 08, and it continues till the end of 2025, which is start of year 26. So this becomes 21 years of annuity. Now we use this formula, present worth formula. So bring it back. When you bring the back amount, remember that it will not go over here, it will not go over here, it will go at the start of year 05. So end of year 05, which is the start of year 06, all the money will come over here at start of 2005. So when we apply this formula, the money will come over here. I should use another color here so that we don't mix up. Let's use green color here. When you apply the formula, present worth formula, P05 will be here. P05 is, just use the formula here, P05 is equal to, the annuity is how much? 1000. Okay, and we have 1.1, I suppose 10% is their interest, so 1.1 raised to power 21 minus 1 divided by, we have 0.1 into 1.1 raised to power 21. So what we are getting is $8,649. And then this amount P05, we have to bring it back to 0, 0. So we have, as you can see over here, we have 5 years more to discount. 1, 2, 3, 4 and 5. Then we have P00 is equal to 8649, 1.1 raised to power 5, and what we get is $5370. Last time when I was teaching this example, some student asked, what is the purpose of bringing this first over here and then bringing it over here? This is a very practical example. What happens normally when World Bank or these lending agencies, they give money, they say, let's say for power plant, the power plant is construction time maybe 5 years. They say that, okay, we will give you the money, and during the construction time you don't have to return us any money. But after the construction is over and the project starts giving its revenue and benefits, then you start paying us back. So you can see over here that they will pay you only this much amount of money, and you will end up paying for 21 years for $1,000. So 21 multiplied by $1,000, you have actually end up paying $21,000, which you borrowed $5,370 only. This is what happens to the developing countries. They give us loans. They say, okay, we will give you this much amount of money, and you keep us paying $1,000 each year for the rest of the life of the power plant, and you just keep paying them for 21 years or whatever. This is just an extreme example. They may have, they call it soft loans. These soft loans are maybe 3 to 4% interest, not 10%, but they come up with preconditions, and these preconditions are very dangerous for the developing countries, because these preconditions put the countries in difficult situation. They cannot put it for example on education purposes or from health purposes. They want that they increase the tariffs, etc., and so on. So this is just to give you example, that this is a practical example when we borrow the money, how it is treated.
Doctor,
Yeah.
I have one question which was asked by students as well. It is understood that we are going to do 21 years from 2006 until 2026.
Yeah.
2005, end of 2005 until 2025.
Yeah.
But it is end of 2005 that we are bringing to the start of 2000. How come we are not considering 6 years? We are considering only 5 years. If you take a look at the flow diagram that you have, if I have the money in the red spot 06, and I want to have the beginning of 00, when I count the slots, it seems to be 6, but we are using only 5 in our calculation. Is there any way that we need to be conscious about how to calculate the number of years at that time?
Sure. Thank you very much for this question. We can see that how this initial formula was started. At the end of year, we are putting amount, and we had F3, and then we generalize this formula to Fn, and that was the future value, and then we have brought this future value to the present value by discounting them 1 plus I raised to power n. This was our future value. When we go with this one, as you can see, there are 3 payments here and 3 over here, and when we have n payments, we have this formula. And then if we want to bring it back to the present value, we divide by 1 plus I raised to power n. As you can see from here, if you want to bring it back over here to 0 time, there are 3 payments here, so we have to bring it 3, 1, 2 and 3, and it will come over here. So here, for example, we have 21 equal amounts, and when we use that formula to bring it P05, it will come over here. This end of 2005 is start of year 2006, as you said already. So when we use this formula, the money will come from here, not here, but at the start over here. When you apply this formula, the money will come over here at the start here. So P will be here. The same way P will come over here, P05, and then we have to make it to 00 value. Then we can see from here there is 5 years of interest period, 1, 2, 3, 4 and 5 years back. So then we use this to bring this money back over here.
So to clarify that this space between 05 and 06, we don't have any interest.
It is developed like that. There is interest going on, of course. When you apply here, the last payment has no interest here. As you can see, when it goes to the future value, the last payment doesn't earn any interest. But then when you bring it back, the interest is there. Okay. So when you bring it back over here, it come over here, and that's what when using the formula, it bring it over here, and then we need to bring it back to 5 years back. Any other questions? No. So we continue with that. Another example, uniform capital recovery formula. This is also very interesting formula, very useful. A plant of capital cost of $50,000 and an expected lifetime of 20 years has an annuity. We might have to find at 10%. We just use the formula of this one, capital recovery, and we have $50,000 present value. We use the formula to get 5,837. This is practical also. For example, you have a present value of any asset, like you have a power plant, and you want to know how much you have to recover annually, you just use this formula to find out what should be the present value how much you have to recover annually. So that's how you can find out, and from there you can also set the tariff, that now you know what is your target, how much you are going to get it annually. You can set the tariff of electricity, for example. So it's very useful formula. And then we have some application exercises. Problem 1 we have already seen, and problem 2 we are going to solve it next time. So I leave this lecture at this time here. We stop it. Thank you very much.